All right, so for chapter 9, we're extending what we learned on chapter 8. We're gonna solve this first one by factoring. And the only thing difference, this isn't a quadratic expression. We're not just factoring it; we're actually solving it. So the first step we factor. The second step we set those factors equal to 0. So the x and x are easy. The signs are easy. I know I got a negative, so opposite signs. And you just kind of think, how do I factor 26? Well, the only way I can think of besides 26 times 1 is 13 times 2. And it checks out. If you take plus 13x, which is done by doing that, and if you take minus 2x, you get the plus 11x. Okay, if for some reason you would put the signs differently, it would give you a negative 11, so you'd swap them. But once you have it factored, you set each factor equal to 0. So you get x equals negative 13 as the solution and x equals 2. Now, for some of them, I'm going to require you to show work, actually factor them, show it out, and write the solution. But you can use your calculator to help you find the factored form, just like we reverse engineered it in chapter 8. You can do a similar thing for the chapter 9 stuff. So quadratic formula, and then you just enter the coefficients. The a is the thing in front of x squared. The b is the thing in front of x. The c is the thing in front of is a thing that doesn't have an x term. So negative, you have to use the negative key. 26. You don't use a subtraction key, otherwise you'll get an error. And look, you get those same solutions. So, but just remember that the negative 13 solution comes from the x plus 13 factor. The positive 2 solutions comes from the x minus 2 factor. So the factor signs and the solution signs, you could say they're opposite, but it's because of the nature of how equations work. Now, the only numbers we'll be working on in chapter 9 that'll be on this test will be numbers 5 through 10. That's solving the quadratic equations. 15 through 19, that's more in solving quadratic equations, but we're going to lean more heavily on the quadratic formula. And number 19, which is an application problem involving mapping height using a quadratic equation. Now, that's going to be in metric units on the test instead of the English units that are on the study guide, but the form will be the same. I'll go into more detail with that later. But next up, 6. So we can still solve this by factoring. This is a difference of perfect squares. So you know the x and the x work out, but it's weird that we don't have a middle term. That should tell you right away these numbers have to be the same, but opposite signs, and it causes the middle cancel out. So you get x equals negative 5 as a solution, x equals positive 5 as a solution. You can write your answers like this, like I did in the previous one, or you can do the little solution set notation. That's fine. I don't care how you write it necessarily. You can write it either way. Some people write like this: x equals negative 5 comma 5 without the solution brackets. I prefer to put the brackets, but there's many ways to write your solutions, just as long as you have negative 5 and 5 are both solutions. Now, graphically is another way to solve this. Even though we didn't, we covered this a little bit in class, but you can use graphs to help you solve that. So I'm going to put x squared minus 25 in the calculator. I'm going to hit my graph in the standard window, zoom, standard. So if you get stuck factoring, you can use the graph. Notice how it hits the 0. It's the 0 at negative 5 and positive 5. So you can use that to help you answer these two. But I just find factoring to be a little bit quicker than doing it graphically most of the time. For number 7, we run into a little snag. The first step in being able to use factoring to solve is I got to have standard form of the equation, which has it in descending order, sure, but this is supposed to be an equals 0 on this side. The problem is that negative 8 is not a 0, so we got to turn it into a 0. How do we turn it into a 0? We add 8 on both sides of the equation. So you get this 80 turns into an 88, and then you just got to kind of figure out how to factor that by guessing and checking. It could be 44 times 2, but that won't give you a 19. You could try a bunch of different things. You could do 4 times 22, different things. But it's going to be probably 8 times 11 that works out. And we know the signs are both negative. And we know this checks out because negative 8 and negative 11 construct a negative 19 in the middle. But your solutions aren't negative 8 and negative 11. Your solutions are x equals positive 8 x equals positive 11. Again, because the work that you kind of do either mentally or writing it down, you add 8 on both sides of this equation like so. So 8 and 11. And again, we can check that by using quadratic formula. Go to your, this is probably the only formula in your calculator at this point, and you can put the coefficients of the, or we could call them the A, B, and the C. But just make sure you don't put 80 in there. That would be wrong. That would give you the wrong answer. You'd have to put 88. You have to get this thing in standard form. You have to get 0 on one side before you're even allowed to use quadratic formula. For number 8, we have the same scenario. We don't have 0 on one side. I want 0 on one side, so let me move this to the other side. That's 4x. So we get x squared minus 1x, or just minus x equals 0. And so, this is a little awkward to factor. But one thing I do notice is that I can factor out an x. I want to factor out an x, I get this. And then here's the thing. Now we just set each factor equal to 0. Set x equal to 0. And then here, set x minus 1 equal to 0. So your solutions are x equals 0. This is really already solved. And x equals positive 1, which you could also write in that solution set notation. Now, if you want to use quadratic formula, it is possible to use it. This is x squared minus 1x. Let me put the 1x squared. Minus 1x. But wait a minute, where's the c term? Well, there's nothing there. So if you want to use quadratic formula, you put 1 as the a, negative 1 as the b. The c is 0, so it's not explicitly given to you, but notice how it gives you the same solutions. So you got to kind of picture it. To be able to apply that quadratic formula, you sometimes have to see what's really not there. Okay, we have two terms. It's a binomial, not a trinomial, so that we get a little awkward when we're trying to factor that. Now, there's actually two ways to do this. Instinctively, what you can go is say, hey, man, I hate when this number is bigger than 1. It would be really nice if I could factor out a 4. In this case, you can. You can't always, but in this case, we can. If you factor a 4 out of both sides, out of both of those terms, you get, oops, that's supposed to be a 25 right there. And then don't stop here. This can be factored further. The 4 is still there technically, but the x squared minus 25 factors out into an x and x, 5 and a 5, plus and a minus. So these solutions here, similar to one we had earlier, are negative 5 is a solution, and x equals positive 5 is a solution. Of course, quadratic formula works, and you can check that, but the other way that you might factor it, and it's still fine to do, instead of factoring out the 4, maybe you just didn't see that, and it's not, there's not really not a problem if you don't factor out the 4. You can still get the answer. Maybe you just thought, oh, 4 is a perfect square, 2 times 2. 10 is a perfect square, 10 times 10. Well, guess what? These factors get these same solutions right here. So there's two ways to do it factoring, and of course you can do the quadratic formula, and you could also do it by graphing. So many ways to solve. All right, we run into this issue again. What we want is this. We want standard form, ax squared plus bx plus c equals 0. The bad news is we don't have like equals 0 like we did in the first couple, but let's do this. Let's move what's here to the other side. So let's move the 5x by adding 5x. Okay, obviously the 5x mixes with that. Mixes with that. Oh, wait, but when I try to move the 8, there's nothing to like put it under. So do I combine it with this or combine it with that? Well, the answer is you don't combine it with anything. You just get 5x squared minus 3x. The 8 doesn't combine with anything because but there's secretly like a plus 0 here, it's hidden. So you just put the minus 8, kind of add it on, and now we have standard form. At this point, you can just factor it. Again, factoring it like this. And if you're having trouble factoring, let me show you the great thing. I'm still going to do it by factoring, but I'm going to use quadratic formula. Go to Program, go to Quadratic Formula. I'm going to use it to help me find the answers. So it's like, I hate when that number is, bigger than 1, and it's too complicated. I don't want to do the thinking. So I'm going to just try quadratic formula and see if it gives me clues for the factors. A decimal, I don't like that. I don't know how to interpret that. But man, this negative 1 I know that if -1 is a solution, then x plus 1 is a factor. Well, since x plus 1 is a factor, all right, then that must mean that, well, I have a plus 1 right here, but how do you get a -8? Oh, we must be 1 times -8. Well, then how do we get the 5x here? Well, x times 5x, so there must be a 5x right here. And in fact, we can see where that 1.6 comes from. If you do 5x minus 8, set that equal to 0, you get 5x is equal to 8. Divide by 5 on both sides, you get x is equal to 8 fifths, which, if you write that as a decimal, is 1.6. I don't care what form you write it in. You could also write it as 1 and 3/5 if you want. These are all, this, and this are all the same answer. The other solution is x equals -1. So any of these, any form of the first answer and x equal -1 are your solutions here. For number 15 through 18, we can continue trying to factor it. But before we do, of course, we got to get it in standard form. We got to get 0 on one side. So you get -3x squared plus 7x plus 10, not minus 10, equals 0. And before I try to factor it, if I try to factor it with this -3x squared, let me show you the problem with keeping that as a -3. If you do like -3x times x, that's kind of, you can get -3x squared that way, or you can do 3x times -3x. But the problem is it makes the signs all weird. Like just makes it really complicated. If you try it this way, you'll notice it just gets a little weird figuring out what signs go where. So if ever you lead with a negative, it's a good idea to factor that negative or that -1 out. And so you get 3x squared minus 7x minus 10 equals 0. And the reason why this factoring out the negative is helpful is because now the sign rules are what we're used to. There's a negative on the end, the signs are different. Whereas here, I would have thought the signs are the same, but now I know the sign should be different. X minus, put a 3x and then a plus. And what I'm not sure is which one's a plus, which one's a minus. But even still, this thing takes a while to get the factoring right. Like to get the 10, I can try 5 and 2. I can try 2 here, 5 here. Those will all be different scenarios. It could be 10 and 1. It could be 1 and 10. But whatever possibility you try, you have to check to make sure the middle term works out. So I'm going to try, first I'm going to try this. I'm going to try doing a 10 right here and a 1 right here. So this will be a -30x if you do these two, right? And then this will be a +1x. Ooh, I get -29x. That is not even remotely close to what I want to get. So it would seem my numbers are off, but before you change the numbers, try changing where the numbers are. So instead of 10 and 1, try 1 and 10. Now, this is going to be a -3x, and then this is going to be a +10x. Oh, that gets a +7x. That's great. Oh, except we don't want a +7x, we want a -7x. So if you want to change your sign, then change the signs. So this becomes the plus and this becomes the minus. Now that's a lot of work to solve that using factoring, and then you still got to set each factor equal to 0. So 3x minus 10 equals 0. So x equals -1 is one solution. And when you solve this, x equals 10 thirds is your other solution. You can write that in decimal form as long as you could do 3.3 repeating. That's fine too, as long as you put the bar over it. Because they didn't ask you to, well, actually they do ask you to round, so just kidding. 3.33 would be, even since they said round to the nearest hundredth, go ahead and do that. But whenever they say round to the nearest hundredth, that's a good clue that factoring is either going to be taking a while or it might be actually impossible to factoring it using whole numbers. So use the quadratic formula. I'm going to use the quadratic formula with the original one. I'm going to put a -3, +7, and then notice how it is important that you move that 10 over, and then a +10. Notice how I get the same answers, -1, and then 3.33, if you round to the nearest hundredth. Now I'm going to do it again, but with the -1 factored out. So I'm going to put it with this one. But notice how the answers we got were -1 and 3.33. I'm going to run the quadratic formula again. If you hit enter after you've run the program, it just reruns it. I'm going to use a +3. I'm going to use a -7. And I'm going to use a -10. Even though I changed the signs, I changed the sign on everything, look at that, it actually still gives you the same solutions. In a different order, but still the exact same solutions. So quadratic formula, really useful for ones that are difficult to factor. For this one, you can try to, for number 16, you can try to factor it, but before you do, of course, you got to get it in standard form with everything on one side but 0 on the other side. I promise you, try to factor this all you want. It is impossible. So you have to lean on quadratic formula. Again, you can do it by hand. -b plus or minus the square root of b squared minus 4ac all over 2a. But, you know, if we understand, like memorizing the formula is just as effective as, looking at the formula. Like if you know how to apply it, and we wrote a program that applies it, so you still have to know how to apply the program. You have to know what the A, B, and C are. That's the really useful part of this formula. The A is the 1, so the number 1. The B is the +4. And the C is, careful, the C is -1 because you got to move that 1 to the other side. So these are your solutions using quadratic formula to do that. But there's effectively no way to factor this by hand. You have to lean on the quadratic formula when it just can't be factored. Okay. So since they want to the nearest hundredth, I'm going to go ahead and do the rounding myself. So this is going to be 0.24 right here, and this one's going to be around the 2 decimal places, -4.24. Those are your two solutions. All right, now for 17, again, they asked us to, some of these might be able to be factored. You can do, actually, 17, you can factor it by hand. But, so first, if you're going to factor it by hand, these numbers are too big. Notice how they're all divisible by 4. You can pull out the 4, and, you get this. And this right here is easier to factor than these big numbers right here. But you know what else works? Quadratic formula. So I'm going to run the quadratic formula, go to program, select wherever yours might be number 1, but I have other programs in here. So select whatever you got. You can put the original number, 12, +16, -28, and then these are our solutions, 1 and -2.33 or -2 1/3. Or I could have even run the same thing, but with 3, 4, -7. Notice how I get the same solutions, 1 and -2 1/3. If you want to do it by hand, that's perfectly okay. If you'd rather do it by hand than use the quadratic formula, sometimes you can. But I'm just saying there will be some on the test, like that last one, like number 16, where you have to use quadratic formula. You'll have to use it at least once. So if I say specifically use quadratic formula, that's a really good clue that you have no choice. But if I don't say use quadratic formula, you will be able to factor. So I use quadratic formula to solve it at first, and that's one option. But if you like factoring it, you can use quadratic formula for hints, or you could just realize, oh hey, we got prime numbers, so 3x here and an x here. I know there'll be a 1 and a 7, so because that's a prime number too. So let's try a 1 here, a 7 here. Now you just kind of figure out what the signs are. Maybe you'll luck out the first time, maybe you won't. Maybe it'll take you 2 tries. Hopefully, let me just try putting a negative here and a positive here. Let's see, that's -7x. That's +3x. Oh, what a tragedy. I get -4x. Oh no, all is lost. What a terrible day. Hey, let's try switching the signs. Yay, switching the signs changes sign. And so this is the proper way to factor it, but we don't want to stop at factoring it, not in the chapter 9 part. These are equations, we want to solve them. So you set the factor equal to 0, x equals 1, set this factor equal to 0, 3x plus 7 equals 0, so 3x equals -7, And so x equals negative 7/3. Another way to write negative 7/3 is negative 2.3 repeating. But they specifically said in the direction surrounds the nearest hundredth. So there are your answers. Again, you could calculate it with the formula or you could factor it by hand. Okay, for number 18, before we even try to factor it, before we even attempt that, you might think, oh, hey, x and x, 3 and 3, yay, let's go work out. No, not yet, because we gotta get a 0 on one side here. So we get x squared plus 6x, and then you gotta move the 25 over, which gives you negative 16, and that equals 0. And just to check my math, yeah, 9 minus 25 for sure is 16. Oof, I'm having trouble thinking of factors of 16 that add to 6. They add, so maybe that they subtract. So you could do x and x. The signs are different. Because the signs are different, they don't add up to get the 6. They really kind of subtract to get the 6. So try 8 and 2. 8, 2, hey, look, it works out. But your solutions are x equals negative 8, because you set this equal to 0, and x equals positive 2. Alternatively, of course, you can use the quadratic formula. If you use the quadratic formula, you run your coefficients in there. 1, 6, but don't enter 9, enter the negative 16, and then 8, and negative 8 and positive 2 are your solutions if you use that. Either way works. Finally, we're going to do an application problem. Now, one thing just to let you know, on the test, this number will be negative 4.9 t-squared instead of the negative 16. I prefer doing this in meters instead of feet, but everything I show you will be working exactly the same. So we want to figure out when this ball hits the ground. Here's what's important that you understand. All right, if the ball hits the ground, and we don't know when it will hit the ground or after how many seconds, we're solving for t. Okay, so, I mean, we solved quadratic equations in all these previous ones, sure. But when it hits the ground, what does that mean? They didn't give us a value for the height. Well, think about it. When you're throwing a ball, so you throw that ball. Yes, that's totally a perfectly drawn human being there. You throw the ball up, what happens? Balls go up, and then eventually gravity brings them down. Well, when you hit the ground, what is your height? Your height is 0. So this is actually what we're used to. 0 is equal to negative 16t squared plus 30t plus 6. And so we just still have a quadratic equation, and let me solve that. I'm going to lean on just doing it. Even though this can be factored, I'm going to lean on doing it using quadratic equation because, I mean, in real life, most of them are not going to be super pretty numbers. You're going to get weird decimals. So why not just use a calculator to find those? Negative 16, 30, and 6 are our A, B, and our C. So, even here, the solutions are actually not nice, pretty numbers. They actually were decimals. So this one would be probably pretty rough to factor. It would not be super fun. So these are your answers. But think about this. If T stands for time, and we also want to know how after how many seconds, here's what actually happens. The negative solutions in most applications actually get thrown away. So actually the answer is just let's say 2.06 seconds. Let's round to the nearest hundredth. But that is how you solve these. So we're just literally, I'm going to ask you, when does it hit the ground? And you just set that equal to the height. You could also answer questions just to give you an example. Let's say I asked you, at what point is the ball 1 foot off the ground? You would put like a 1 right there. At what point is the ball 2 feet off the ground? You could put a 2 in here. And, you could substitute those numbers in. Some things you couldn't put in there, like you couldn't say, at what point is the ball 100 feet off the ground? Because in this scenario, the ball will probably never go 100 feet off the ground. But the idea is that the height, when they say when it hits the ground, ground means the height is 0. Substitute 0 in place of the height. That's it. One more thing I'll add before I go. Even though solving by graphing is going to be less familiar to you than solving by factoring and all that. If you look at this graphically, okay, I'm going to look at the graph of this quadratic equation. Finding the right window can be difficult. That's what makes this harder. But let me just zoom out a little bit or do zoom fit. That's zoom option 0, and you can see how this graph behaves. And actually, let me make some smart choices here. Let me just go back to this, something that's really close to the standard window. So negative time doesn't really make sense. So if you don't really follow like why I'm choosing the numbers I choose, don't worry about it so much. The y minimum, I'm just gonna make it like -1 so I can see the axis there, and the y max, let's make it 25. Okay, and this allows you to actually see the path of that ball. So before you throw the ball, these values before the t equals 0, these negative values don't make sense because you haven't thrown the ball yet. That's why we toss out the negative answer. But the ball goes up. As time progresses forward, the ball goes up. It reaches a max height of, somewhere around 20 feet. You can actually calculate that if you want. And then it eventually drops. And here's where it hits the ground. Right here, you notice how that's really close to, there's 1, this is 2, this is 3, that's 4. It's awfully, awfully close to 2. So you can graphically, that can help you understand this. But again, using quadratic equation can help us find those solutions very easily. But the path of the ball's height increases over time until it hits its max, and then it starts falling. What goes up must come down. The path of the ball is not a parabola. It's just tossed straight up, and it goes straight down. This is just the height over time. And that's it.